So discrete time system is the one which will be having the input signal and output signal. Both the input and output signals are of discrete signals only. So what is discrete time signal system? Discrete time system will perform some operation on input signal so that input signal will be transformed to the output Y. Okay, so how do we write y of n? Y of n can be written as operation on x of n. So y of n is given as, so how do we represent this operation? We represent this operation with a t. Okay, this will be nothing but the transformation. So it transforms the input signal into the output signal. Okay, so operation here we denote with t. Okay, now we see the classification of systems. Okay, so in the classification of systems, the first one is static and dynamic systems. The second one is causal and non-causal systems, linear and non-linear system, time invariant, time varying system, stable, unstable systems, invertible, non-invertible systems, FIR and IR systems. So these are the seven classification of discrete time systems. First, we'll discuss what is static and dynamic systems. So what is static system? Static system is also called memoryless system. Okay. So what is memoryless? The present output depends only on the present input. Okay. So then it is called memoryless. So you don't require any memory to save the past or future input values. So that is why it is called memoryless system. Static system is nothing but memoryless system. So what is here? The response is what? Response is nothing but the output. The output is will depend only on the present input. Okay. So then it is called memoryless system. So what are the examples of memoryless system you see here? Y of n is equal to x of n. Y of n is the output, x of n is the input. Y of n is equal to 2x square of n. So we are just squaring the input signal, that's all. Okay, so that is why 2x square of n. Okay, now we'll discuss what is dynamic system. Dynamic system is also called memory system. What is memory system? Here the response or output of the system depends on the past or future values of input or past values of output also. Okay, so the output of present output of the system depends on past or future inputs or past outputs also. Then it is called dynamic system or memory system. Now see this example, y of n is equal to x of 2m. How do you check whether it is a memory system or not? Now we substitute for n is equal to 0. So when n is equal to 0, y of 0 should depend upon x of 0. Okay. If y of 1, so substitute n is equal to 1, y of 1 is equal to x of 2. What happens here? For n is equal to 1, the present output, n is equal to 1 is the present output, y of 1. It depends upon the past output, that is future output, that is x of 2. Okay, so 2 is the that is the future output value, future input value. Okay, so the present output depends upon the future input value. So that is why this system is called memory system, because it has to store the future input value. Similarly, see this here. Now substitute n is equal to 1. So if you substitute n is equal to 1, we get y of 1 is equal to x of 1 plus x of minus 1. So what is x of minus 1 is the past input value. Okay. So the present output depends upon the past input value. So it has to store the past input value. That is why. So whenever you have a system which depends, whose output depends upon past or future inputs or past outputs, then that system is called dynamic system or memory system. Okay. Now, for example, you take this case here, substitute n is equal to 0, y of 0 is the present output, plus y of minus 1 is the past output, plus y of minus 2. 4y of minus 2 is the past output, that is equal to x of 0. So what is this here? Present output depends upon the past output values. Okay, these are the past output values and present input value. Since it is depending upon the past output values, so what type of system it is? It is called memory system. Okay. So like that we will be finding whether the system is memory system or not by substituting n is equal to 0 or n is equal to 1 and n is equal to minus 1. You have to substitute positive and negative value. At least one positive and one negative value you have to substitute. Then only it is easy to find out whether the system is memory system or not. Okay. So if you see this example, y of n is equal to x of n plus 2. Okay, so it depends present input, present output depends upon future that is future input value. So this is memory system. And whereas here if you see this is memoryless because there is no addition or no what is that arithmetic operation is performed for n. Okay, so if any arithmetic operation is performed on n, then it becomes memory or memory system. Okay, here you see here we have n minus 2 because we have n minus 2. What type of system it is? It is memory system. Okay. Now we see the second classification, that is causal, non-causal system. So when we say that the system is causal, the system is said to be causal when the output of the system at any instant depends only on present and past values of input. It should not depend upon future values of input. Then the system is said to be causal. Okay. So the output of the system depends only on present and past values of input. It should not depend on future input values. Then it is called causal system. Okay. So uh, for causal system, the impulse response or output does not begin before the input function is applied. That is, the causal is non-anticipatable. Okay, causal systems are real-time systems. Okay, so for example, we are applying input. So when what is that impulse response of causal system is zero for n less than zero. Since what is that we are doing? We are applying impulse response. No? When we are applying impulse response is applied at n is equal to 0. So the output of the system will appear only after n is equal to 0 only. Okay, so that the impulse response h of n will be 0 for n less than 0. Okay, because we are applying input only at n is equal to 0. Our output present from n is equal to 0 onwards. Before n is equal to 0, what is the output? Output will be 0. So the impulse response h of n will be 0 for n less than 0. Okay. So these are the examples of causal system. Substitute n is equal to 0 here now. If you substitute n is equal to 0, y of 0 is equal to 0. X of 0, no? N is 0 anyway, here x of 0. So our present output depends upon the present input value. Substitute n is equal to 0 in this equation. If you substitute n is equal to 0 in this equation, y of 0 is equal to x of minus 2 plus x of minus 1 plus x of 0. Okay, y of 0 is the present output, x of 0 is the present input, x of minus 2, x of minus 1 are the past of input values, x of minus 2 and x of minus 1 are the past input values. So the present output depends upon the present input and past input values. Okay, so what type of system it is? It is causal system. Okay, the present output should not depend upon the future input values. Okay, so a system is said to be non-causal. Okay, when it is called non-causal, if the output of the system depends on future values of input also. So if it is depending upon one or more future values of input also, then the system is called non-causal system. Okay. So see this example here, y of 0 is equal to, see substitute n is equal to 0 here, y of 0 is equal to x of 0 plus x of 0 will be reality. Substitute n is equal to 1. Y of 1 is equal to x of 1 plus x of 2 we get. Okay. So what happens here? The present output depends upon the future input value. So since present output depends upon the future input value, it is non-causal system. The present output should not depend upon future input value. Okay, see this example also, y of 0 is equal to x square of 0 plus 2x of 2. What is x of 2? X of 2 is nothing but future input value. So this system is non-causal system. Now see here, this is what? This is causal system. Okay, because present output depends upon present input as well as past input values. Whereas this one is non-causal and this one is also non-causal. Now substitute n is equal to minus 1. So y of minus 1 is equal to x of 1. No? So this becomes non-causal. Okay. And say this one is causal system only. Y of n you have, x of n you have. Okay. So the present output depends upon the present input. So this is causal system only. Okay. Now we see this linear and non-linear system. Okay. What is linear system? A system that obey the principle of superposition and homogeneity both. That system is called linear system. Okay. So what is principle of superposition? Principle of superposition is nothing but if you apply the input x1 as the input, say if you are getting y1 as output, if you apply x2 as input and we are getting output as y2, now if you are applying input as x1 plus x2, okay, then output should be y1 plus y2, okay. Similarly, what is homogeneity? If you apply ax1 ax1 as the input, the output should be ay1, okay. So then the system is said to be linear. If these two conditions are satisfied, then it is said to be linear. What is homogeneity? See here, homogeneity will produce, say for example, if you apply x1 as input, x of n as the input, y of n is the output. Now if you apply a x of n as the input, we should get a y of n. Okay. If you are getting output as a y of n, then it is satisfying homogeneity property. Now what is superposition? For example, if you are applying x1 as the input, we are getting output as y1. Okay. If you are applying x2 as the input, we will be getting output as y2. Now if you apply input as x1 plus x2, if we apply input as x1 plus x2, what should be the output? Output should be y1 plus y2. Then it is called superposition theorem. Okay. Then what we have to do? Now, if we are applying the input as ax1 plus ax2, if we are applying input as ax1 plus bx2, then what should be the output? The output should be ay1 plus ay2. Okay, then the system is said to be linear. If this condition is not satisfied, then we say that the system is non-linear. So how do we check this? Well, what is the first condition here is wherever you have x, replace x with x1, write the output as y1. Okay, and wherever we have x, replace x with x2, write the output as y2. Okay, now in the place of x, write x3. In the place of x3, what you have to write? ax1 plus bx2. Okay, check y3. What is y3 you are getting? If your y3 is equal to ay1 plus by2, okay, then the system is said to be linear. Otherwise, the system is said to be non-linear. Okay, so we see this example. First example, y of n is equal to n square x of n. Okay, what I told you to substitute in the place of x, substitute x1. Okay, so write the output as y1. Okay, now y1 of n is equal to n square x1 of n. Okay, now in the place of x here, okay, in the place of x here, write x2. So x2 of n. The corresponding output we will be writing it as y2 of n. Okay, then in the place of x we write x3. So what is x3 now? x3 is ax1 plus bx2. Okay, so write this output as y3. Okay, write this output as y3. Okay, so now we just separate this. This we will be writing it as a n square x1 plus b n square x2. So what is n square x1? N square x1. See here, n square x1 is nothing but y1. N square x2 is nothing but y2. No? So what is y3 now? Y3 will be a y1 plus b y2. Okay, since y3 is equal to ay1 plus by2, this system is said to be linear. Otherwise, the system is said to be non-linear. Okay. Now, similarly, you take the second example here. Y of n is equal to x of n plus 1 by 2 x of n minus 2. This type of problems are very important. What is our first step now? Wherever we have x, substitute x1, write the output as y1. Wherever the second step is wherever we have x, substitute x2, write the output as y2. Okay. So then in the place of x, write x3, whereas x3 is ax1 plus bx2. Okay, and check y3, whether y3 is ay1 plus by2. If y3 is equal to ay1 plus by2, then we say that the system is linear. Otherwise, we say that the system is non-linear. Okay. Now see this example. This is the example we are taking. What I told you, wherever we have x, here we have x of n, write x1. Here we have 2x of n minus 2. So we write 2x1 of n minus 2. Okay. Write this output as y1 of n. So what is y1 of n? Y1 of n is equal to x1 of n plus 1 by 2 x1 of n minus 2. Now write y2 of n. Y2 of n will be equal to x2 of n plus 1 by 2 x2 of n minus 2. Okay. Now what you have to do? Write in the place of x, write x3. In the place of x, write x3, where x3 is equal to what? Ax1 plus bx2. Okay. So wherever we have, see here, x3 we are writing. What is x3? x3 is ax1 plus bx2 of n plus 1 by 2 ax1 n minus 2 plus bx2 n minus 2 will be 2. Okay. Now check, this is y3. No? So y3 we got like this. You check whether y3 is equal to a y1 plus b by 2. If y3 is equal to a y1 plus b by 2, then it is linear. Since in this case y3 of n is not equal to, see here, these two are not same, a y1 plus b by 2. So this is non-linear system. Okay. So like that we have some examples here. Now we'll check what is time variant and time invariant system. Okay. So what is time invariant system? Time invariant system is nothing but the system behavior does not change with time. Okay, behavior of the system is independent of time. Then it is called time invariant system. The time invariant system is also called shift invariant. Okay. So when do you say that the system is time invariant here? What we have to do, if there is a change, shift in the input, there is a corresponding shift in the output also. Okay. So for example, if you are applying x of n as the input to the system, say the y of n is the output. Now if you apply input as x of n minus k, if you get the output is equal to y of n minus k, then we say that the system is shift invariant system. Otherwise the system is shift variant system. Okay. So how do we check this here? So to check this, what is that we do? We just shift the input. Okay, wherever you have x, x should be replaced with x of n minus k. Write that corresponding output as, see here now. So write the corresponding output as y of n comma k. So what is y of n comma k? By applying input as x of n minus k, what is output we are getting? That is y of n comma k. Then what we do? We replace wherever we have n. We replace all n values in the equation with n minus k. That is nothing but y of n minus k. Okay, so y of n, where n should be replaced with what? N minus k. Now, if y of n comma k is equal to y of n minus k, then we say that it is shift invariant system. Otherwise, we say that it is shift varying system. Okay. So now we see this example here. So we see this example. What we have to do? Wherever here, what is that? Y of n is equal to x of n by 2. No? X of n by 2. What you have to do? We just apply delay to this. Okay. So if you apply delay to input signal, Just add minus k to whatever index you have in the x. Okay, just add minus k. Okay, so see here x of n by 2 minus k. Shift the input signal by k units. Write the corresponding output as y of n comma k. Now, y of n minus k, wherever you have n in the equation here, in this equation, wherever we have n, all n values will be replaced with n minus k. So, what is y of n minus k here? X of n minus k by 2. Okay. Now, just observe this y of n comma k is not equal to y of n minus k. So, what type of system it is? It is shift varying system, okay, or time varying system. Let us take this example. So if you see this example, if you apply the shift to input, okay, so we get x of n minus k, no? We get x of n minus k. Write the output as y of n comma k. Okay, now write y of n minus k. Now we also got x of n minus k for that. Okay, now since y of n comma k is equal to y of n minus k, okay, so it is satisfying this condition. So what type of system it is? It is time invariant system. So next classification is stable and unstable system. What is stable system? If you apply bounded input, okay. Bounded means what? The amplitude of the signal is finite value, okay. That is mod x of n value is less than or equal to m, okay. So when the amplitude of input signal is having some finite value, the output of the system should also be finite. Then the system is said to be bounded input, bounded output system, okay. So a system is said to be bounded input, bounded output, stable only if bounded input produces bounded output. Okay. The output of such a system does not diverge or does not grow unreasonably large because your input is finite. The output should also be finite. Then we say that the system is stable system. Otherwise, the system is not stable system. Okay. What is stable system? If you apply the input mod x of n value is less than or equal to mx, okay, some finite value, its value is less than infinity for all n, okay. Then what should be y of n output? Mod y of n should also be less than or equal to some magnitude m by, whereas m by value is less than infinity. Then the system is said to be bounded input and bounded output system, okay. For the system to be bounded input and bounded output, what is the condition here? So this is summation n is equal to minus infinity to plus infinity. Mod h of n value should be less than infinity. So then only the system is said to be bounded input and bounded output. Okay, this is the necessary condition, necessary and sufficient condition for a discrete time system to be stable. Okay. Now we'll see the proof of this. Now we know how to write y of n. Y of n is the output of the system where x of n is the input and h of n is the impulse response. So the output of the system will be denoted with the convolution as a mean. So what is the formula of convolution? So it is summation k is equal to minus infinity to plus infinity x of k h of n minus k. Okay. So we are finding the absolute value, so we take absolute value on both sides of this equation. So mod y of n is equal to mod summation k is equal to minus infinity to plus infinity x of k h of n minus k. Okay. Now what is that here we are doing? We are applying absolute to the terms inside the summation. When you apply this absolute to the terms inside the summation, whatever value you get, that value will be greater than this value. Okay. So that is why mods, see here the modulus is outside. If modulus is outside, this value will be less than or equal to if you apply modulus to the terms inside. Okay. Now since we are applying modulus to the terms inside, so this value will be always greater than, that is right hand side values will be greater than the left hand side value. Okay. So just now we have discussed what is x of k. X of k is having some bounded value, finite value. How do you write it as mx? Okay. Mod x of k value is less than or equal to mx less than infinity. So since it is constant, we are writing outside the summation here. See here, we are writing mx outside the summation. Mod y of n is less than or equal to mx. Summation k is equal to minus infinity to plus infinity. Mod h of n minus k. Now, what we do, we change this variable. Now substitute m is equal to n minus k. Now if you substitute m is equal to n minus k, okay. Now this can be written as summation n is equal to minus infinity to plus infinity, where k is some constant. Mod h of n value is less than infinity. Okay. When you get this value less than some infinity, only when this is less than infinity. That is, this mod what is that summation k is equal to minus infinity to plus infinity mod h of n minus k value. If this value is less than infinity, since it is finite and this is also finite, then you get finite values of n. So what is the condition here? This value should be less than infinity. Okay. Now what we do, we replace m with n, so that summation n is equal to minus infinity to plus infinity, mod h of n value should be less than infinity. If this condition is satisfied, then only if you apply bounded input, okay, you will be getting bounded output. Otherwise, you will not get bounded output. Okay. So for the system to be before stable, what is the condition? So the condition is summation n is equal to minus infinity to plus infinity, mod h of n value should be less than infinity. Then only we say that the system is bounded input, bounded output, stable system. Otherwise, the system is unstable system. Okay. See here, these are the examples of bounded input and bounded output systems. Here, A to D. All these are bounded input, bounded output system. E to F. See here, the values are increasing. No? If the values are increasing, what happens? The amplitude will also increases. So output will also be, when n is equal to infinity, what happens to x of n value? Becomes infinity. If x of n becomes infinity, output will also becomes infinity. Yes or no? So these are the examples of unbounded signals where the amplitude of the signal will be increasing. So since you are doing summation here, since here, see here, we are adding all the samples. Since we are, its value is always increasing here. What happens when you add all the samples? The value becomes infinity. Okay, so that is why this is also unbounded. Okay, so this one is also unbounded because the values are increasing. Okay, and if you add all the values, what happens? It becomes infinity. Yes or no? So this is also unbounded. Okay, so these are the examples of unbounded signals, whereas these are the examples of bounded signals. See here, the amplitudes are reducing, and here also it is having constant amplitudes, whereas here the values are having finite range. Okay, here also it is having some finite range. So if it is having finite range, then it is bounded only. If it is having infinite range and the values are increasing like this, then it is unbounded. Okay, so now how do we check the stability of the system? So we will be checking the stability of the system. Say if you apply x of n is equal to del of n. Okay. So whenever we have this type of equations, what we have to do? We should apply input x of n as del of n. Check the output. Okay. So if your input is x of n is equal to del of n, then what is the output? Output will be the impulse response. How do you write output? Y of n is equal to h of n. Yes or no? H of n is equal to a into what is x? X is del number, del of n minus 7. Okay. What is del of n minus 7? Del of n minus 7 is having the value only at n is equal to 7. If n is not equal to 7, what is the value will be 0. So here you see, if we are applying a impulse signal, we are getting a finite output only. We are getting output only at n is equal to 7. At all other values, the what is the value will be 0. Okay. So now you check this summation n is equal to minus infinity to plus infinity mod h of n value, whether it is less than infinity or not. Now if you take this summation n is equal to minus infinity to plus infinity, what is h of n now? A into del of n minus 7. A into del of n minus 7. Okay. And it is having value only at n is equal to 7. Only at n is equal to 7 we will be getting A, and all other values will be 0. So A plus 0 will be A only. That is why what happens here, since A is a finite value, this system is stable. Okay, this is the stable system. Okay, similarly here